and we have 10 problems under this exercise, and in all the problems we are applying basic proportionality theorem and also its converse. We already have proved the basic proportionality theorem in detail in one of the previous videos, so please do watch. Now we are going to explain what is its converse, and proof is not needed, children. Only basic proportionality theorem proof is needed in this year. Okay, so only the statement. Before moving to its converse, we can revise what is the basic proportionality theorem and its statement. What is the statement, children? If a parallel line divides two sides of a triangle in two distinct points, so the sides are divided in the same ratio. Okay, that means if DE parallel to BC, this DE divides AB and AC in the same ratio. That means AD by DB equal to AE by EC. This is basic proportionality theorem. Here what is the condition? Here, in order to get this ratio must be equal. The condition is DE must be parallel to BC. This is the condition. This if so implies AD by DB equal to AE by EC. This is basic proportionality theorem. So how can we explain its converse part? If a line divides two sides of a triangle in the same ratio, so what is given? The two sides are divided in the same ratio. So it must be given, that is AD by DB equal to AE by EC. If so, implies that line is parallel to the third side. Okay, that is BC. Implies DE parallel to BC. Okay, this is the converse. This is a converse of BPT. Idea is clear, children? Any triangle, any two sides of a triangle divided in the same ratio. See, children, AD by DB. AB divides into two parts and its ratio is equal to the ratio of the second part, that is AE by EC. Okay, which implies that line is parallel to the third side. That is a statement. If a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. Using these two very important theorems, we are going to start exercise 6.2. We are going to start exercise 6.2, problem number 1. In triangle ABC, DE is parallel to BC. We have to find out EC. For that, we have given the measurement of AD, DB, AE. See, children, what is given in the question? That is DE parallel to BC. That means we have a triangle and DE is the line segment which divides this other two sides of the triangle, AB and AC in two distinct points, and also DE is parallel to BC. So which means you can apply basic proportionality theorem. Okay, that is if a parallel line divides two sides of a triangle in two distinct points, so the sides are divided in the same ratio. Okay, the only condition is DE must be parallel. That is given in the question. Okay, so since it is given that D is parallel to BC, so we can apply directly basic proportionality theorem by BPT, basic proportionality theorem. Okay, we can write AD divided by DB. This AB is divided by this point D. The line segment D divides both sides in the same ratio. Ratio means that other side, that is AE divides EC. This ratio and the first side is divided into two parts, that is AD by DB. Both the ratios are the same because of basic proportionality theorem. Okay, and the next is very simple. All the three measures are given, only E is needed. Okay, we are going to substitute the values of AD and DB and also AE in this given equation. 1.5 divided by 3 equal to 1 divided by EC. Okay, so you can just cross multiply. Okay, so 1.5 into EC equal to 3 ones are 3, and since we need EC, we are keeping EC alone by taking this 1.5 into the denominator. So see, in the RHS we have 3 divided by 1.5. See children, if we have a decimal number in the denominator, we are converting that into a natural number by multiplying with the powers of 10. Okay, depends on the number of decimal places after the decimal point. Since we have only one decimal point, 0.5, okay. So with the 10 you can multiply. So 3 into 10 divided by 1.5 into 10. 3 tens are 30 and 1.5 into 10 is 50. 15 in 30, 2 and unit is 2 centimeter. That means EC equal to 2 centimeter. See children, ratio its double is 3 and 1 its double is 2. So ratio is being same. So EC is equal to 2 centimeter. Quite simple problem. Now the second sub question. Here the same idea. We have a triangle ABC and DE parallel to BC. Okay, if a line, that is parallel line drawn to intersect other two sides into two distinct points. That is okay here. Other two sides means AB and AC. Okay, this line DE dividing this AB and AC in two distinct points. That is at D and at E. That means you can apply basic proportionality theorem. Okay, to apply basic proportionality theorem, always the line must be parallel to BC. That is given. So, by basic proportionality theorem, BPT theorem, okay, we can write, since here DE parallel to BC, okay, that is AD divided by DB. This AB, these two portions are AD by DB, and in the next side AC also can be written in the ratio form, that is AE divided by EC. Next step, we are going to substitute the values. AD is the required side portion, AD, so that is unknown, and DB we can substitute as 7.2 and AE 1.8 divided by 5.4. Okay, first of all, if you want, you can solve this RHS part. Okay, what I told in the previous question, if the decimal number comes in the denominator of a fraction, to being how many decimal places here? 1. That is point after point we have 4, 1 decimal place. So you can multiply both the fraction, both the numerator and denominator with the 10. Okay, so I am going to make that idea here, that is 1.8 into 10 divided by 5.4, equivalent fraction, that idea. Okay, so that you can easily solve this problem. This side 18 divided by 5.4 into 10 means 54. Multiplication of a decimal number with the powers of 10. Just shift the decimal point to the right side by the number of zeros. So one place we move to the right side, so 54. So 18 and 54 we can reduce. Fraction always should express in the least form. Okay, we know that 18 and 54 is a multiple of 18 3 times. For those who feel difficult, we can divide with 2 or 3 or 9. All are the factors of this 18 and 54. Okay, so I am going to divide with 9. So 9 and 18 2 times. Here 6 times. Okay, in the next step you can definitely write 1 and 3. So 1 by 3. Or directly, if you know the multiple of 54 is a multiple of 80, 3 times, that is okay. So anyhow we have 1 by 3 in the RHS, but we have AD divided by 7.2 equal to here 1 by 3, AD by 7.2. But what we need AD is needed. Okay, we need to find AD. So AD equal to this 7.2 will go to RHS. So under multiplication 7.2. See children, here not the point. Here the decimal number comes in the numerator. That doesn't matter. If a decimal number comes in the denominator, that case only we are multiplying with the 10, 100 according to the number of decimal places. Isn't it? Okay, so you can see some of the digits, that is 7 and 2, that is 9. So you can divide 7.2 with 3. 3 is a whole number. So, okay, so no problem at all. So 3 in 7, 2 times. Okay, 2 3s are 6 and 1 remainder. So 1 along with the 2, that is 12. That is 3 in 12, 4 times. That is 2.4 cm. After getting the answer, you have to write its unit. It's given in centimeter. So AD is equal to 2.4 centimeter. Okay. Now the second question. E and F are points on sides PQ and PR of triangle PQR. For each of the following case, state whether EF parallel to QR. EF parallel to QR. Okay, here we have three different cases. Okay, so we can consider the first case. For that I have given the measures of each portions. Okay, that is given. Okay, see children, first of all, how can we show that this EF parallel to QR or not? That means in order to show that the line segment joining any two points of two sides of a triangle is parallel to the third side, you can apply converse or basic proportionality. Converse. Okay, that means to check whether this EF parallel to QR, you apply converse of BPT. Okay, what is the converse says? Okay, if any line which divides two sides of a triangle in the same ratio, if it is same ratio, okay, that means that line is parallel to the third side. Okay, that means if we can show that, okay, this PE, this PQ divided by the point E, okay, that means PE, the ratio PE by EQ, and this side PR, that is PF by FR. If these ratios are same, you can say that EF parallel to QR. Understood, I guess, clear children? If we can show that this side, its ratio, and the side of this side PR, being these two ratios, if we can show that same, you can conclude that EF is parallel to QR. Okay, so we are going to check whether these ratios are same or not. That means for that P is given as 3.9. Okay, and EQ is given as EQ is 3. Okay, and 3.9 divided by 3. Here 3 comes in the denominator. So you can just divide 3 in 3 one time and 0.39 1.3. Okay, if the decimal number comes in the numerator, it doesn't matter. Okay, if it comes in the denominator, that case only we are multiplying with the powers of 10. Okay, and here PF and FR we can write down the measurement. PF is 3.6 and FR is 2.4. Here the denominator is decimal number. Okay, so you can multiply with the 10. So 24. Here multiply with the 10, 36. So 36 and 24 are the multiples of 12, isn't it? Okay, those who feel difficult to get that number, you can easily, being it is even number, start with the 2 in order to get a simplified form. Okay, so I am going to divide with the 12 itself. 12 in 24 2 times. 12 in 36 3 times. 3 by 2. Here we should get the answer in decimal form. Here we have 1.3. So we can do one more step. So 2 in 3. 1 time and remainder 1. So a decimal point, after putting decimal point, you can consider that as 10. So 2 in 10, 5. That is 1.5. That means here we have seen that P by Q EQ equal to 1.5. PF by FR equal to 1.5. That is, both are different. That means this is not equal to the second ratio PF by FR, which means this EF is not parallel to QR because of converse of BPT. You can state that. Converse of BPT. Okay. In the same way you can do the remaining problem. See, PE, here PE is given as, we can substitute here in the second case. PE is 4 divided by EQ. QE and EQ both are same, 4.5. Okay, you can take it's multiplying with 10 because the decimal number, so it become 45. Here become 40. 4 into 10, 40. So being multiples of 5, so 5 in 8 times 40 and 9, that is 8 by 9. This is PE by EQ, this side. PE by EQ. And if you take the second side, that is in case of PR, in case of, we are discussing now the second one. Okay, PF is given as, what is PF here? PF is 8 and RF and FR both are same 9. 8 by 9, see children? 8 by 9 is PE by EQ. Here PF by FR also 8 by 9. That means those two sides PQ and P are divided in the same ratio. Which means here we have seen that both are in the same ratio. Which means EF is parallel to QR. The same idea, converse of BPT. Concept is clear, children? Okay. Now the third case, that is here PQ is given as 1.28. PQ means the whole side. Okay, and PR is given as, PR means this side, that the one of the side. And at the same time, there we have discussed, you see that video children, I have given a detailed explanation of this 6 result. Okay, if we have the whole length, if the ratio is in terms of whole length of one of the side, that is what I mean is PQ in terms of PQ, okay, divided by PE. If I am taking the whole length of this side and in the denominator the upper part, okay, of this EF, that is PE, okay, and that will be equal to, in the other side, that means the whole length PR. You have to take, if you are taking numerator as the whole length of the side, you have to take in the RHS the whole side, okay, length of the whole side, that is PR, divided by this upper portion, that is PF. That is clear, children? Okay, that is basic proportionality theorem is applicable not only for this manner. If a line is parallel line is drawn, okay, then you will get the sides are divided in the same ratio. Okay, and at the same time, this is also you can easily prove. Okay, and also the other result also we have proved. So, but here we need only this result. Okay, here we have given in terms of the whole length of one side and the other side, and then the denominator the first portion. So if you can show that these two ratios are same, okay, by converse of BPT you can say that EF is parallel to this side QR. What I meant is, children, this basic proportionality theorem has other result also in terms of that whole length of the whole side. Okay, not only if this small portion PE by EQ equal to PF by FR, that is okay. And he see children PQ by EPE, okay, and so if so PR by PF. And second case is, third case is, you can write PQ by EQ, the denominator EQ, here also PR by FR, that also possible. And you can take the reciprocal of all these three. So you will have 6 results from basic proportionality theorem. Okay, you can apply in converse if you can show that any of these ratios are the same. By converse of BPT, you can say that this line is parallel to this. In short, that is converse of BPT is not only for this. If you can show that this is okay, these two ratios are same. Okay, you can say that this line EF is parallel to QR. Understood? So that is our aim. So PQ is given as what is the measurement of PQ? Here in the third case 1.28 divided by PE, that is 0.18 equal to. We can get this value first. If we can show that this, you can write down. Okay, so we are going to find its value separately. First PQ by PE. Okay. So being it is decimal in the denominator, two places are here, 8, 1, 8. So 100. So 1.28 also multiply with 100 means shift to the decimal point from here to right side. So 120 divided by 18 comes. Okay, you can start with the 2, children. Yes, so 2 in 18, 9 times. Okay, here 2 in 12, 6 and 4. 64 and 9. not the multiple, so we can keep that as it is. And here comes PR and PF. What will be the value of PR and PF? See, PR is given as 2.56 divided by PF is given as 0.36. That is 256 divided by 36. Okay, so we can again, being both are even, you can start better to, if in case of big numbers, start with the 2. Okay, so 2 into 1 time, 2 in 5 2 time, and remainder 1, so in 16 8 times, and in 36. Okay, 2 in 3 1 time, and remainder 1 16 8 times. So 128 divided by 8, again even number, you can divide with the 2. So 2 in 12, 6 times and 4, and here comes 64 by 9. Here also we got 64 by 9. PR by PF also, that ratio also we have seen that 64 by 9. That means these two ratios are same. Which means this, in the third case, EF is parallel to QR. Okay, so in order to check whether EF is parallel to QR, you can apply this result also. Okay, so this is all about the second question. Now the third question, if LM parallel to CB and LN parallel to CD, show that AN divided by AB equal to AN divided by AD. Now the third question, if LM parallel to CB and LN parallel to CD, we have to show that AM divided by AB equal to AN divided by AD. That is a question. Okay, so we can easily get this answer. Okay, by looking to the figure, children, you can see that upon this side AC, two triangles are given. Okay, that is triangle ABC and triangle ADC have a common side AC, isn't it? AC. And when you consider the first triangle, this side of the common side AC, okay, you can see that this line LM parallel to this side CB. That means if in a triangle, okay, a parallel line divides the two sides of a triangle, which means that two sides are divided in the same ratio by basic proportionality theorem. That is what is happening in this case. See children, here in triangle ABC, we have a line LM parallel to CB, which means these two sides are divided in the same ratio because of BPT theorem. The same idea you can apply in the second triangle ADC. Why? Because we have given that LN parallel to CD. Okay, which means these other two sides, AC and AD, are the other two sides of this triangle ADC. So these two sides are divided in the same ratio. That means AN divided by ND equal to AL divided by LC. Idea is clear, children? And what we have to prove? We have to prove that AM divided by AB. See, identify the sides. AM divided by AB. Okay, so children, if you are directly applying this basic proportionality theorem, we will get in this manner. AM by MB equal to AL by LC. Okay, but we have to make a simple change. That means by the result of basic proportionality theorem, we have some result we have proved in that video. Just to see that video. See children, there we have seen that if you start in this manner, if the small part, that is AM divided by AB, that can be equated to in the second triangle, okay, that is AN. Okay, this part from this, the vertex A divided by the whole side. That manner you have to take. I will repeat children. That means if you consider triangle ABC, in triangle ABC, okay, since ML or LM parallel to CB, that is given LM parallel to CB. Okay, that means you can apply basic proportionality theorem. But when you are writing that result, okay, being what is asked, AM by AB, AM and AB. That means you have to take in that way. That is because of the result. Okay, instead of AM by MB, okay, you will easily get this result also same from this basic proportionality theorem. That means we have to write this in the form AM by AB. So in this side, how we can take AL by AC, the whole side. Okay, the big side, the whole length should come in the denominator and this part in the numerator. This side also AM divided by the whole side AB. That is the way, then only we can reach into this answer. And is clear, children? Both are correct. Okay, but in order to get the required result, we have to write that form. That is the only change. Idea is clear? Okay, so by BPT, what we can write, children? AM divided by AB. Okay, so you have to take this from ABC, AL divided by the whole length. Okay, that is LC. Okay, that is AL divided by this AC. Okay, in the first side AB, how we have taken? Here we have taken AM. Okay, and the whole length AB. Okay, in that way we have to take. And in the second triangle ADC, okay, in triangle ADC, which line is parallel? LN parallel to CD. LN parallel to CD. By BPT theorem, we can apply if so. If a line parallel to one side of a triangle by BPT theorem. In here also you have to take, see children, AN by AD should come. In that manner you have to arrange. That means AN and the whole length AD. See children, this is AN and the whole length is AD. So I am going to write in that manner AN divided by AD equal. So that side AC also should be written in that form. AL, okay, divided by AC, the whole length. So that means AL by AC. Idea is clear? So this can be equation number 2 and this is equation number 1. Now from equations 1 and 2, see AL by AC, AL by AC, which means you can equate the other side. That means other ratio, that is AM by MB equal to AN by ND. These are LHS. Okay, that is AM divided by AB equal to AB equal to LHS of the second equation, AN divided by AD. See children, AM by AB equal to AN by AD. Is it clear? Now the fourth question. Here DE parallel to AC and DF parallel to AE. We have to show that BF by FE equal to BC by EC. That is the question. And the figure is given. See children, from the figure, since DE parallel to AC, that means this big triangle should be considered first. Why? Because this DE is a line parallel to that side of the triangle AB, that is AC, parallel. Which means here we have DE parallel to AC. So you can apply basic proportionality theorem. We have a triangle and a line is parallel to, okay, one side of a triangle. That means the other two sides are divided in the same ratio. Understood? So children, what we have to prove? So in base, if we are applying basic proportionality theorem, you see that we have so many results. We have 6 results, you know. Okay, so from which way we can express? That decides what we have to prove. See that what we need to prove. That is here BF by FE and BE and EC. So this side BC, okay, look into this side BC. Okay, this BC is divided. This BC is one side of the triangle ABC. This divided into BC, BE and EC. Okay, that means you can write here from the vertex B, this portion B, don't consider now this F now. Okay, so this side BC, the whole side BC divided by this point E in this way, that is BE divided by EC. You have to write that expression in this form because we need that term. Okay, that means BE by EC from the vertex B. Same way, the other side AB also expressed in that manner from B, that is BD by DA. It is clear why we are writing in this manner is clear, children. So we are going to consider triangle ABC since which is a line parallel DE parallel to AC, one side of the triangle ABC. By BPT theorem, okay, we can write in starting with this manner, that is BE by EC, because we need this term, okay, this ratio. So from this BD divided by AD or DA, doesn't matter, this can be equation number 1. So this we got from this because DE parallel to AC, that is given. And secondly, we have given DF parallel to AE. See that from the figure, which is here we already round this point F. Here is this F comes here, so this is F. So DF is parallel to AE. See children, DF parallel to AE. So which triangle we have to consider? We have to consider triangle having the side AE. See children, AE, because this line is parallel to AE. So which triangle? ABE. So triangle ABE, this triangle. You have to consider this triangle and DF parallel to AE. Okay. So in triangle ABE, okay, since DF parallel to AE, okay, same idea, okay, by BPT theorem, okay. See children, which we should get BF and FC should come, okay. So BF and FE, see children, from the vertex B, so BF and FE. So in this side, how we can write B. Now the fifth question, in triangle PQR, DE parallel to OQ. O is a point inside the triangle PQR, okay, and DF parallel to OR. See the figure, okay, and we have to show that EF parallel to QR. That means we have to show that this line EF parallel to QR. See, this is what we need to show. See children, in order to prove that two lines are parallel, especially in case of triangle, okay, we can definitely apply converse of basic proportionality theorem. In order to show that the sides are divided in equal ratio, we are applying basic proportionality theorem. And in order to show that two lines are parallel, we are applying converse of BPT. Understood? Okay, so here we have to show that EF parallel to QR. So we can easily reach into this idea, this result, by using converse of BPT. Okay, so we can start with what is given. Okay, here in the beginning, what is given? DE parallel to OQ. So identify which is a triangle need to be considered first. DE parallel to OQ. See children, this OQ is one side of a triangle POQ. This triangle, look into this triangle. Okay, POQ. What is given? DE, here we have a line which is parallel to one side of the triangle POQ. So we can apply basic proportionality theorem. Okay, if a parallel line divides two sides of a triangle, okay, in two distinct points, the sides are divided in the same ratio. Okay, so from that we can start. Okay, that means in this case, first we are considering triangle POQ. Okay, so in triangle POQ, what is given children? DE parallel to OQ, DE parallel to OQ. So, if so, we can apply basic proportionality theorem by BPT. Okay, see children, here we can write PE by EQ. We are starting with the vertex P. So PE by EQ equal to PD by DU. Okay, so this side PU and this side PQ of triangle POQ divided in the same ratio. Why? Because EF parallel to OQ. Okay, which implies by BPT theorem we can write PE by EQ equal to PD this way. Okay, by DO. Okay, this can be equation number 1. And in the second case, what is given? DF parallel to OR. So that means you have to consider a triangle having one of the side is OR. Okay, and here DF being parallel to OR. Okay, so in triangle POR, that triangle, okay, that means this POR. Okay, this is the second triangle. Okay, so in triangle POR, okay, since DF parallel to OR, you can apply PPT theorem. Okay, parallel line DF parallel to OR. So by BPT theorem, this side PO and that side, the second side PR, divided in the same ratio. That is PD by OD equal to PF by FR. So I am going to consider that side from the vertex P, okay, PF by FR, PF by FR, okay, which is the side PO, that is PD divided by DU. Okay, so this can be equation number 2. See, from equation 1 and 2, you can see that the PD by DU, okay, same for both RHS, the same ratio. That means you can equate the LHS part of first and second equation. So from 1 and 2, you can equate LHS P by EQ equal to this one, PF by FR. Okay, what we need to prove? We have to show that EF parallel to QR. What we have got after applying BPT theorem upon these two triangles, we have now PE by EQ equal to PF by FR. That means this side PQ and this side PR. Okay, of a triangle PQR. This PQ and PR are the sides of big triangle PQR. Okay, these two sides are divided in the same ratio. That is what we have got from equation 1 and 2. Okay, that is PQ and PR divided in the same ratio. PE by EQ. That side is PF by FR. They are equal. Okay, which means if you can show that the two sides are divided in the same ratio. Okay, that means that line is parallel to the side QR of triangle PQR. Okay, which means because of this line segment EF, okay, this side PQ and PR are divided in the same ratio, which means that line is parallel to this side of triangle PQR, that is QR. EF, which means, okay, EF parallel to QR. This is because of converse of BPT. That is the proof. We have showed that, we have proved that EF parallel to QR by converse of basic proportionality theorem. Okay, that means here the line which divides other two sides in the same ratio, which means that line is parallel to the third side. Two sides of the triangle PQR is divided in the same ratio, which means that line is parallel to the third side of triangle PQR. That means EF is parallel to QR. Okay, so this is all about this section. So the remaining problems we will continue in the next video. So thank you children, thank you for watching and supporting my channel.